Hi everyone, in this video we are going to take some questions from the topic of reflection of light. Okay, so quite a good number of questions we will do, and they are not super difficult but they are interesting. So we have two plane mirrors, M1, M2 let's say, and the angle between them is given 70 degree. The ray of light falls on the first mirror at an angle 20 degree with the mirror, okay, with the mirror, not with the normal, with the mirror. So normal will be here, right? So these two angles are given. We are supposed to find total deviation after reflection from the two mirrors. So this light here is falling at what angle of incidence? Well, this must be 70 degree because total angle between normal and mirror is 90 degree. So if this is 20, this must be 70. So this is the angle of incidence. So light will be reflected here like this. So this will be also 70 degree. Now to know what will happen here, I have to draw normal. But to know the normal here, I need to know this is the mirror and this light which is hitting here may hit this way, it may hit this way, right? So anyway it may hit, right, depending on these angles. So how to find angle between normal and the light in both the cases? Very simple. Always try to find angle between the ray of light and the mirror first. So always try to find this angle first or this angle first. For example, if this is theta, this will be what? 90 minus theta, isn't it? So before trying to find angle between incident ray for this mirror and the normal here, try to find this angle, which is angle between the incident ray and second mirror. This is incident ray for second mirror, right? You may be thinking, sir, this is reflected ray, but that is reflected ray for first mirror. That's why I say whenever multiple reflections happen, reflected ray of the first mirror becomes incident ray for the second mirror. And that's why we say image made by the first mirror will act like object for the second mirror. This principle is very useful for later problems. So try to remember. Image made by first reflection will act as object for the second reflection. So how to find this angle? Let's say this angle is theta. Well, this is 70 given. What will be this angle? Well, if this is 20, this is also 20. And interior angles of a triangle, if you add, you should get 180. This angle is 70 degree, right? So theta plus 70 plus 20, which is 90, must be 180. That means theta is what? 90 degree. That means this light is hitting the mirror at 90 degree with the mirror. So normal will be here itself. So here the angle of incidence is 0. That means this light will go back this way. And then that light will come here and again go this way. Right? So if you ask what is the total deviation after reflection from here and then reflection from here and then reflection from here, then the total deviation is 180 degree. Isn't it? Because this light is going back as this light. And after reflection from this mirror, remember it will retrace the path because light follows reversibility principle. So if light goes this way after reflection, and if you put a mirror here perpendicularly, then light will retrace the same path. This is called reversibility principle. So this light is going that way. So therefore total deviation is 180 degree, right? Let us see the next question. So we have a screen and on the screen at this point there is a source of light. It sends light perpendicularly on a plane mirror which is kept this way. So this is the initial position of a plane mirror. So light falls perpendicularly, so it will come back perpendicularly, isn't it? So there will be a spot here. Now they have turned the mirror by a small angle of 2.5 degree. And we learned in the class that when mirror turns by theta, reflected ray turns by what angle? Do you remember? 2 theta. That is because if you rotate the mirror by angle theta, the normal will also rotate by angle theta. The normal will also rotate by angle theta, isn't it? For example, if this is your plane mirror, this is your normal. So if you rotate the plane mirror, normal should also rotate by same angle, isn't it? So now the light from the source is falling at an angle of incidence with the normal theta, remember, because now this is the new position of mirror. So this is the new normal. So now light is still coming in the same way, right? Incident ray is still same. So now the incident ray is making what angle with normal? Theta. So reflected ray should also make the same angle theta. And therefore the spot on the screen will be formed somewhere here, isn't it? So they are asking what is the displacement of the spot. So this y we have to calculate. Now the screen and the mirror are at a distance of 2 meters. Okay. So what will be this angle? That angle will be 2 theta. So this is where the spot is formed now. Okay. When you turn the mirror by some angle, and let us call this m dash, the new position of mirror. So therefore, to find this distance, from this distance is given and this angle is also given theta. So we know this 2 theta. I can use tan of 2 theta, right? Opposite is y, adjacent is 2 meter. So what will be y? Twice of tan of 2 theta. However, theta here given is very small. It's 2.5 degrees. And if you convert into radians, you have to convert into radians, remember. So it will be 2.5 into pi by 180 degree, right? So degree will cancel and you will get radian. So that will be how much? 25 by 10 into pi by 180. 5 2s are 5 5s are, and this will be 5 3s are 15, then 3 carry, 5 6 are 30. So this will be pi by 272, isn't it? So this much radian, and this is quite a small angle because pi value is 3.14, right? So this will be 3.14 divided by 72. So since this angle will be very small, we can use the approximation. The tan of angle is approximately same as angle when the angle is very small. So we can write this as 2 into 2 times theta. This 2 theta will be 2 theta because tan of phi is phi, right? So tan of 2 theta will be 2 theta. So this will be 2 times 2 into theta is what? Pi by 72. And that will be the answer in meters. So this will be 2 3s are 6, 1 carry, 2 6 are 12, 2 18s are 36. So pi by 18 meters. Let us see the next question. So here there is a boy. This is a boy, okay, whose height is h, and he is in front of a plane mirror which is at a distance d. So here we have to keep a plane mirror, okay. And behind the boy there is a father, his father, whose height is 2h, double height of the boy, and he is standing at a distance 2d from the mirror, which means d from the boy, isn't it? So this is father. So here we have to keep mirror so that the boy can see full image of father. So we have to find the minimum length of the mirror required for the boy to see full image of father. Now for the boy to see the image of father, light from the father's head should reach his eyes, the boy's eyes, and light from the foot of the father should also reach the eye of the boy after reflection. So where should I keep the mirror so that light from here reaches here? So let me just do by trial and error method. So something like this, isn't it? Because remember, you have to obey law of reflection. So these two angles should look same. So here there should be some point of the mirror, right? There has to be a mirror here, right? Then only the light will be reflected this way. Clear, right? Okay. Similarly, light from here to reach the eye of the boy, it should go somewhere like this and then here. Okay, it should look, you should try to obey the law of reflection, right? Okay. So there should be some mirror here in order for this reflection to happen. So therefore this is the minimum size of the mirror or the length of the mirror that is required. Now how to find that? Well, if I extend this rays, okay, this would be like image of this point. Why? Imagine light was going this way. Then light would reflect this way from reversibility principle, right? So if light came this way, light will reflect this way. If light went this way, light will reflect this way. So if I extend this, this would be actually image of this point, which means this one will be at the same distance d behind the mirror, isn't it? So now you can see two similar triangles, the big one and the small one here, right? So let us call this A, B, C, and this is D, C I used here, so this is D, E. So in similar triangles, what happens? The ratio of corresponding sides are equal. So left side divided by left side should be equal to right side divided by right side. So if you take the big triangle, this opposite side, which is 2h, divided by opposite side of this triangle is the length of the mirror, which we have to calculate. So L should be equal to this adjacent side of the triangle, this triangle, the height you can say, that is 3D, isn't it? Should be the ratio of this divided by this side. This is the corresponding side, which is how much? D. So for this is for triangles ABC and DBE, which are similar triangles. And for similar triangles, this divided by this should be this divided by this. So D gets cancelled, so L will be equals to 2h by 3. So that would be the answer. One thing I forgot to mention, that here we are assuming the eye and the head are approximately in the same place, or this height is neglected compared to the total height of the boy. Let us see the next question now. So there is an object here which is at a distance 10 centimeter from a plane mirror whose length is 27 centimeter, and this object is along this bisector of this mirror. Okay, and from that object 10 centimeter this side, an observer is moving along this line AB. Okay, now they told when the image of this object, okay, image is first visible to observer, the observer starts from rest. So u is 0 for observer with acceleration 2 meter per second square. Find the time for which the image will be visible. So now, when will he first see the image of this object? Well, light from here will go this way. Light from here will go this way, right? So the extreme light, by extreme I mean the light that hits the edge of the mirror. This is the normal, so this will be reflected somewhere here. Okay, these two angles should be same. So this is the first time the object while coming this way will see the image, because when the observer was here, he will not see the image because to reach there, light has to reflect from here, right? But there is no mirror here. So, and when he is coming this way, obviously this light will reach him, the light which falls at smaller angles. And when he is opposite, this light after reflection will reach him, isn't it? So, this is the first time when he will see the image of this object at this position, and that is when he starts with at t0. It starts with from rest with acceleration 2 centimeter per second square. Now how long will he see the image? Till this light will again reflect this way. So till this point, isn't it? So now we need to know how much distance is this. So once I know the distance, then using kinematics I can find the time taken, because acceleration is given as constant. So now you can see the image of this O will be wherever this rays will meet after you extend, and this distance will be also 10 centimeter. So like in the previous question, we are going to use similar triangles. So let us say this is L. So this side of the big triangle divided by this side of the small triangle must be this side of the big triangle, which is 30, divided by this side of the small triangle, which is 10. So L will be 0 will cancel, 3 7s are 21, 2 carry, 3 2s are 6, 81 centimeter. So now we can use the formula S equal to ut plus half at square to find the time for which he will see the image, right? So in this part he is going to see the image. So in this much time starting from here, because here he started, right? So time 0 started from here. So from here to here he will see the image. Distance covered is 81, initial velocity is 0, acceleration is 2 t square. So t square is 81, so t will be 9 seconds. So that would be the answer. Okay. So let's see the next question. We have two plane mirrors M1, M2, which are kept parallel, and you know in that case if you put an object you will get infinite number of images. From the second mirror the object is at 5 centimeter, and from the first mirror the object is at 30 centimeter. You have to find the position of fifth image in M2. Now you know that this light will reflect this way. So image will be formed here, right? That is the first image in the mirror M2, and that will be at a distance of 5 centimeter. Then again that light will go here, and for this mirror this light will act like object, and one image will be formed by reflection here. So that way you will get multiple images. Similarly, light from here will go this way and then reflect here. For this reflection, the reflected ray will appear to come from here. So that is the first image, which will be at 30 centimeter in M1. This is the image in M1. This is the image in M2. So this is for M1. This is for M2. So that way multiple images will be formed. Now to find the position of fifth image in M2, if you draw the ray diagram, it will take too much time and it will be confusing. So the technique that I discussed in the class was, write here mirror M1, here write mirror M2, and then you know the first image from M2 will be formed at 5 centimeter from M2, and first image in M1 will be formed at 30 centimeter from M1. Okay. Now what was the technique I told? Add the distance between the mirrors this way. So you have to add 35 centimeter, which is the distance between the mirrors. So if I add 35 here, it will become 65, and here if I add 35, it will become 40. Then here if I add 35, it will become 100. Here if I add 35, it will become 75, isn't it? Here if I add 35, it will become 135. Here if I add 35, it will become 110, right? 35. Here if I add 35, I will get 145. And that is the fifth image. So here I will stop. So this is the fifth image. This is the first image corresponding to this, remember. So first, second, third, fourth, fifth. So the fifth image position should be 150 centimeter from M2. Okay, so this is your two mirrors, M1, M2. So fifth image will be at a distance 145 centimeter from M2. From M1 if they ask, then you have to add 35 to this, that will be 180. Okay, you can check because this is 35. So let us see the next question. We have two plane mirrors which are separated by 0.2 meter and the length of the mirror is given as 2 root 3 meter. A ray of light strikes this mirror just inside at an angle of 30 degrees, just inside. Okay, we have to find the maximum number of times the ray undergoes reflection, because after it hits here it will keep on reflecting this way, right? So we have to find the maximum number of times the ray undergoes reflection, including the first one, before it emerges out. So let's start solving this question now. Remember, since the light should reflect, this light is actually slightly inside, remember, inside, okay? So this light will be reflected like this at same angle of incidence 30 degree, and this would be the normal, and then light would again hit this mirror. This would be the normal, and then light will again reflect, isn't it? So if I assume our mirror is just till here, and remember, since this light is slightly inside, this ray will be slightly outside this, so this light will just go out, remember. Okay, because for here reflection to happen, this light should be slightly inside. So if you follow that way, this light will be slightly outside this mirror if your mirror was up to here. I am doing this so that we can simplify the problem and find the formula to calculate the number of times the ray will reflect, including the first one. So here how many reflections happened? Can you count? 1, 2. This one you cannot count, right? Just outside. So 2 reflections happened. Now how to find that 2? Remember, this distance if I write is x, then by geometry this distance is also x, because this angle is 30, this is also 30, this is also 30. So this is x, this is x. So you can see then the number of reflections will be simply this whole length, which is actually in the problem 2 root 3 divided by x, isn't it? Because how many x is there here? 1x, 2x. So for this problem, 2x will be the length of this mirror, which was given 2 root 3. But 2 represents what? Number of reflections which happened. So this 2 would be, number of reflections would be 2 root 3 by x. So in general, this would be the number of reflections. Now how to find this x? That can be found from this side. This side was given 0.2 meter. So this is x, this is 30 degree, this is 0.2, so this is 0.2. So I can use tan 30 degree. Let us call this equation 1. So tan 30 degree will be opposite by adjacent, which is 0.2. So if you cross multiply, x will be 0.2 into tan 30. Tan 30 is sin 30 by cos 30. 1 by 2, root 3 by 2. So 1 by root 3. Now if you put this x here, what will be the number of reflections? So number of reflections will be, put this x here. 2 root 3 by 0.2 and root 3 will go up. So this will be root 3 into root 3 will be 3, so it will be 6, it will be 2 by 10, 10 will go up, isn't it? So this will be 2 3s are 6, then 30 reflections. Okay. So in the next question, they have given that this vector represents the direction for incident ray. So this is a vector I bar which is in the direction of incident ray, and this is a vector which is in the direction of reflected ray. They are asking you to find angle of incidence on the plane mirror. So if you assume this is your plane mirror and this is incident ray vector and this is reflected ray vector, then the angle between this vector and this vector is not this, remember, it is this. Okay, so angle between two vectors is found by joining their tails. So if one vector is here, one vector is here, you have to translate this vector and then you have to say the angle between the vectors is this, not this, remember. Okay, so this vector is here, this vector is here, so if you translate this vector here, this would be the angle between incident ray vector and reflected ray vector. Now from vector study we know how to find angle between two vectors. So I bar dot r bar, if I take, it will be magnitude of the first vector, magnitude of the second vector, cos of the angle between them. That's how dot product is defined. So cos theta will be dot product divided by mode of the first vector and mode of the second vector, isn't it? Now if you take dot product of these two, you will get I cap by 2 dot I cap by 2 will give you 1 by 4. Then root 3 j cap by 2 minus root 3 j cap by 2 will give you minus 3 by 4, right? We have to multiply the x component and the y component. So x component is 1 by 2, here x component is 1 by 2. So it will be 1 by 4, and here x component is root 3 by 2, here it is minus root 3 by 2. So when you multiply, you will get minus 3 by 4. Then I have to take mode of the first vector, that will be under root half square plus root 3 by 2 square, which will be 3 by 4, into mode of second vector will be same, because when you take mode you have to square the components, right? So the minus doesn't matter. So x component square means what? This is half square, so this will be 4. So half square will be 1 by 4 plus here minus root 3 by 2 square will be 3 by 4, isn't it? So your cos theta will come here minus 2 by 4, so minus 2 by 4 divided by, this will be 4 by 4, this is 1, right? So this is just 1 into 1, isn't it? So this will give you minus half, that means theta is 180 degree. So if this is 180 degree, you know that this is angle of incidence, and law of reflection says angle R is also angle I itself. Now this whole angle is 180, right? So 2I plus theta is 180, isn't it? So if I substitute theta, I will get 2I plus 120 equals to 180. So 2I will be 60, I will be 30 degree. So that would be the answer. Okay. So let us see the next question. So here they have kept a plane mirror and a concave mirror whose radius of curvature is given 20 centimeter. Okay, this is just the modulus, okay, the magnitude. Object is kept at a distance 15 centimeter from the concave mirror, and the distance between the two mirrors is given 22.5 centimeter. So you have to find the position of image after two successive reflections, starting first from concave mirror, because light can go here also first, right? Light can go this way, light can go this way. So they are asking you to consider this reflection. Okay, so here the most important part is to remember that when multiple reflections happen, image made by first mirror will be object for the second mirror. Please don't forget. So since we have to study reflection from concave mirror first, so we will first study reflection at concave mirror. So we'll try to find the image distance. So what is the focal length? Radius by 2, and for concave, remember cave, when you go to caves you get negative thoughts, remember that, right? So for concave mirror we take negative focal length. So what is the radius of curvature? Minus 20, because it will be left side, incident ray is coming this way, but center of this will be on the left side, so we have to start from the pole. So from pole, when you go to center, it is opposite to incident ray, and by sign convention we take it negative. So radius of curvature is minus, so minus 10 centimeter is the focal length. Object distance is how much? Minus 15, because object is to the left of the mirror, so opposite to incident ray. So let us find image distance. So mirror formula is 1 by V plus 1 by U is 1 by F. U is minus 15, F is minus 10. So 1 by V will be 1 by 15 minus 1 by 10. LCM of this will be 30, 15 2s are, 10 3s are. So V will be minus 30 centimeter. So we found that the image formed by the concave mirror for this object is at a distance 30 centimeter from the mirror, remember, because these calculations were done for concave mirror. So all these distances are measured from the pole of the concave mirror, right? So object was at 15 centimeter, image is at minus 30. Now minus 30 means it is to the left, right? And since this is 22.5, it means image will be beyond this mirror also. So somewhere here, let's say. So this is the location of the image formed by the first reflection. And that will be at what distance from the concave mirror? 30 centimeter. Now what is the rule? The image made by the first mirror will now act as object for this mirror, isn't it? So this will be now object. So this will be like object distance. How much it will be? Well, this is 30 and distance between the two mirrors is 22.5. So if you subtract, you will get 7.5. So this is 7.5 centimeter. And you know, for plane mirror, it is very easy to find the image. If object is in front of the mirror, image will be same distance behind the mirror, isn't it? And in case of virtual object, if object is behind the mirror at a distance x, a real image will be formed in front of the mirror. So if this is your object behind the mirror, this will act like virtual object for this mirror. So image will be formed in front at what distance? 7.5. Okay, this is 15. Oh, so if you see carefully, this is 22.5, this is 15. So distance of the original object was 7.5 only. That means this image will be exactly on the object. So the final image, okay, is at a distance 7.5 centimeter from the mirror, which means it is exactly at the same place where there was the original object, right? So light would have gone something like this and then like this, and that light, since it forms image here, should come this way. Okay, so the reflected light would meet here. However, because there was a mirror, plane mirror here, it further reflects and finds the final image here itself. Okay, so let's see the next question. So we have two concave mirrors whose focal lengths are given 20 centimeter, 20 centimeter. Remember, this is only the magnitude. Okay, while putting in the mirror formula, we have to put with sign. And for concave mirror, we know focal length is negative, so while substituting, we have to put minus 20. Now one object is kept at a distance 30 centimeter from this mirror. They are asking what should be x, or they may also ask what should be the distance between the mirrors, right? Because if you find x, you will find this also. 30 is given already, right? So if this is 10, this will be what? 40. So you have to find the value of x so that a ray of light ray, retrace, very important word, retrace its path after second reflection. They are asking you to assume first reflection is on M1. Light can go this way also, this way also. So you have to assume those rays which are going this side to solve this problem, because they mentioned first reflection is on M1. Now for first reflection on M1, let us find the image distance of this, right? So for reflection at M1. So what is mirror formula? 1 by V plus 1 by U equals 1 by F. Now for the first mirror, this is the object, light is coming this way, remember. So this is opposite to the pole. So remember, light is coming this way. This is incident ray. And you have to start from the pole. So from pole to object, it is opposite to incident ray. So you have to choose negative. Be very careful. It is not like right side is positive, left side is negative. If your concave mirror is kept this way and light comes this way, then this is positive, this is negative. But if your concave mirror is kept this way, this is also concave mirror, same as this. But for this concave mirror, you have to show light this way. Why will you show light hitting the back side, right? So if light hits this way, this will be positive and therefore this will be negative. So object distance, though it looks like right side of the mirror, be careful, it is opposite to incident ray. So U is minus 30 and focal length for concave is minus, right? So it will be 1 by 30 minus 1 by 20, 60, 30, 2s are 23s are, so V will be minus 60. So we found that the image is 60 centimeter from the first mirror. Minus means it is opposite to incident ray, this side. Now this side means where? Here or here? That we still have to think, right? So understand one thing, that they told that the light ray should retrace its path after second reflection, and second reflection will happen here. Now let us think, when does light ray retrace its path? Well, if you remember in class I told, light ray will retrace its path only when it hits perpendicularly to the mirror. So for plane mirror, if it comes like this, it will go back like this. It will retrace the path. And for spherical mirror, the light should be along the normal, which means it should be along the center of curvature, right? So if this mirror has center of curvature here, and any light that goes this way or this way will just retrace its path. So for light to retrace after hitting a spherical mirror, it is important that the object, for a concave mirror, the object should be at the center of curvature. Okay. Now who will be object for this mirror? Not this, remember, because we assume light going this way first. So for this mirror, this was object, and wherever is the image formed by this mirror, which is I1, that will be object for this mirror. And we already know, to retrace the path for this mirror, the object should be at center of curvature. And who is the object for this mirror? The image made by the first one, right? And where it is? 60 centimeter from the first one. So 60, let's say, is somewhere here, okay? So therefore your image I1 should be here. And since you want that to be the center of curvature, this should be also the center of curvature. C, let me write. And if it is center of curvature, this distance will be what? R. Okay. So 60 plus R must be 30 plus X. Or in the question, if they ask distance between the mirrors, then you could have told directly 60 plus R. But here they asked this X, right? So this 60 plus this R should be this 30 plus this X. Think about this carefully. And what is radius? Remember, here when I write R, it means the modulus, because this is distance, right? So we are not using this R in some mirror formula. When you use in mirror formula, there we have to put sign. But here I mean this distance plus this distance should be this distance plus this distance. So it is just the length. So this R is here modulus. Okay, be careful. So what is R? Well, F is equals to R by 2. So R's magnitude will be 2F. And 2F here is how much? 40. Because F is 20. So this is 2F. F is 20. So 40, 30 plus X. If you simplify, you will get 70 as the answer. Okay. Now, as I told, ray diagram is not needed, but if you want to see, then it should be something like this. Light going from here will reflect here like this, and since it is passing through center of curvature of this mirror, this will hit perpendicularly and light will go back. Okay. So after first reflection, second reflection, and again third reflection, light will go back to this object. Okay, so after third reflection, the image will be formed at the object itself. Okay, let me show once more. First reflection, second reflection is going normally to this mirror, and therefore it will retrace the path. Third reflection, and retrace means it will go back to the same path. So after third reflection, image will be formed here itself. Try to remember that also. Okay. So let's see the next question. Here there is a convex mirror whose focal length is given 10 centimeter. Okay. Now it is cut into two equal halves. They should have mentioned along the principal axis. So if this is your convex mirror and this is your principal axis, we are cutting the mirror along this axis. Okay. So that you have now two halves like this. Okay, this half and this half separated. After cutting, what they have done, they have displaced the two halves. One above this initial line where the object is kept by 2 millimeter, and one below the same line 4 millimeter. We have to find the separation between the images formed by the two halves. Now the important thing here is, if this is your convex mirror and if you cut this part, the radius of curvature will not change. If you cut this part also, the radius of curvature will not change. So focal length will not change. Okay. However, after cutting, when you displace it up, the principal axis will shift. So please understand that this line is no longer the principal axis. So this will be the principal axis for the first half. Let me call this first half M1. And this will be principal axis for the second half. Let me call it M2. That is very, very important to realize. So this is your principal axis for first half, and this is principal axis for the second half of the mirror. That is because, see, if this is the mirror and this is the principal axis, so if you cut like this and you take that part up, the pole still is there only, right? So that will be still principal axis. The principal axis is a line passing through pole and center of curvature, right? So this is not principal axis, be careful. Now here is your object, a source, which is kept how far from the mirror, that has to be given. So it is given at a distance of 10 centimeter. Now, since it is convex mirror, we know image form will be virtual. So it will be behind the mirror, right? Somewhere here. And there is no need to find the image distance because object distance is same for both the mirror, right? This is the object distance. This is the object distance, isn't it? For example, if I give you this convex mirror, and this is principal axis, remember, principal. And if I give you object here, which is not on the principal axis, still object distance means what? This, no, this is object distance and this is the height of the object, right? So if I put an extended object like this AB, this is called object distance, this is called height of the object, isn't it? So for the first half, this is the principal axis. So this is the height of the object, which is down, remember, down, okay, HO. And this is the object distance. Similarly for the lower half, since this is the principal axis and this is the object, this will be the object height, HO dash, let me write. But object distance is still 10 centimeter. So object distance is same, focal length is same for both. So image distance will be same wherever it is. Okay, so image distance will be same. Let me try to find the height of the image, because in the question we are supposed to find separation between the images formed by the two halves. Now image distance will be same from the pole, but height I want to know. Height means how far the image is from the principal axis. And remember, this is the principal axis for the upper half. So for that we will calculate magnification first. What was the formula for magnification? F by F minus U. This formula you must remember, okay? So focal length for convex is plus, object distance for both is this side minus 10, opposite to incident ray. So this will be 10 by 20, 1 by 2. So image height in the first case will be m into object height, which is half into, what is object height? Well, this is object height from principal axis to object. It is downwards, so it will be minus 2 millimeter. Okay, minus means it is down from the principal axis. Okay, down from this principal axis. Be careful. So this is minus 1 millimeter, right? And image height in the second case will be, magnification will be same for this mirror also, because F and U are same for this object. So object height in the second case, so this is second case, okay, half into, what is object height? Positive, it is up from this principal axis, so this is 4, so that is 2 millimeter. Okay, so that means if this is your principal axis, first principal axis, then what is the image height? Minus 1, so it is below the principal axis. By what distance? 1 millimeter. 1 millimeter. This line, okay, so this is this line. And this line is your principal axis for the lower half. What is the image height? 2 millimeter, so it is 2 millimeter. So this is 2 millimeter. Remember, it is up, so this is down, this is up. This is I2. And what was the distance between the two principal axes? 2 plus 4, 6. So what will be the separation? This would be the separation. And that separation will be, total distance here is 6. Out of that, this much is 1, this much is 2. So if you subtract those two, you will get 3 millimeter. And that would be the separation between the two images. Okay. So here's another interesting question. Here's a concave mirror whose focal length is given 30 centimeter, the magnitude. and there is a plane mirror. The distance between them we don't know, we have to actually find that. And a source of light is kept at a point midway between them, midway. Okay, now thus they are saying that a beam of light on the plane mirror, so this time we have to first consider reflection at plane mirror first. So the beam of light on plane mirror becomes parallel to optical axis, matlab principal axis, after reflection through concave mirror. So they are not saying after reflection here it becomes parallel to, how it will be parallel to principal axis like this. This is stupid diagram because normal will be here, no? So light will never be this way, light will go that side of the normal, isn't it? So please understand, this is not how light will go. But they are saying that light after hitting the plane mirror, obviously it will go to the concave mirror, right? So they are saying it becomes parallel to optical axis after reflection through concave mirrors. Matlab this way it should become. Here there is chance because for concave mirror normal can be somewhere here, if center is somewhere here, right? So how to do this problem? Well, again, many times I have told you that image made by first one will be object for the second one. So for plane mirror, this is the object distance d by 2, right? So image will be formed at same distance d by 2. So this is your what? Image made by the plane mirror. Now for your concave mirror, this will become object, right? And how far is that object? 3d by 2. How 3d by 2? Because this is also d by 2. Now if this is object for the concave mirror, if this is your object, let me write here O. Actually O is here, so okay, so you should not get confused. So this is actually image made by plane mirror, which will now be object for this mirror. So for this mirror, this is like object, so let me write O. What is that? Now if they said that after reflection light should go parallel, that means where this light will meet the reflected light. Parallel means it will meet at infinity. That means image formed by this mirror is at infinity, and therefore object must be at focus. That you remember, right, for concave mirror. So therefore this must be focus of concave mirror. Therefore this 3d by 2 must be focal length. Length, remember the magnitude plus distance I am saying. I am not substituting f in mirror formula. Focal length is 30. So d will be how much? This will be 60 by 3, 20 centimeter. Okay, so this distance must be 20 centimeter. Let us see the next question. Here they have given you a convex mirror of focal length 10 centimeter and object is at a distance 10 centimeter in front of the mirror. And at this instant it is moving with a velocity. This is object velocity with respect to mirror. However, in this problem, the mirror is at rest. So I can write this as just object velocity with respect to ground. That is because object velocity with respect to mirror means object velocity minus mirror velocity. And these two are with respect to ground. So if mirror is at rest with respect to ground, this will be 0. So these two will be same. Okay. So this 4 centimeter per second is object velocity with respect to ground along principal axis. And at that instant when the distance between object and mirror is 10 centimeter, we have to find velocity of image. So we have standard formula, velocity of image with respect to mirror is minus m square times velocity of object with respect to mirror. Let me just calculate the magnitude first, then direction we will see later. Now here mirror is at rest, so this will become velocity of image m square times velocity of object. And what is magnification formula? F by f minus u, isn't it? So F is 10, 10, U is, remember left side of incident ray is coming this way, object is opposite to incident ray from the mirror, right? So minus 10, that will be 10 by 20, that will be half, isn't it? So this will be 1 by 4 m square, and object velocity was given 4, so 1 centimeter per second. Now when object is coming this side, where will be image? So you know that when object, see, this is at focus, if you see carefully, focal length is 10. So image, this is your center is somewhere here, let's say. So this is your normal. So light will reflect this way. So this is where your image is formed when your object is here, right? Then when your object will come closer, it will hit at bigger angle. So image will be formed here. So if this is your second object, not second object, second position of object, this will be second position of image. So when object is going here, image is coming here. Okay, so it is 1 centimeter per second towards left side. Let's see the next question. So they have given you two mirrors, one is plane mirror and one is convex mirror. Object is kept at a distance 36 centimeter from convex mirror, and object is kept at a distance of 24 centimeter from the plane mirror. So some light will go this way, right? And that will form image due to the plane mirror. And some light will go this way, that will form image due to the convex mirror. Now the question says, if no parallax is found between the images, the virtual images formed by the two mirrors, then we have to find the radius of curvature of this spherical mirror or the convex mirror. Obviously first we have to find the focal length. Now what does no parallax means? Now in first PU, if you remember, in units and measurement they will teach you that if you keep your thumb like this, and if you see the thumb from right eye and left eye, you will see it will shift. That shift is called parallax shift. And if that is because one object is near and the background is far, that's why you see there is some shift. But if object and background are in the same place, or if two things are in the same place, then when you see this from the right eye, then with the left eye, you will see both of them will move together. So that means there is no parallax. So when two things should not have parallax, it means they should be at the same position. Okay. So when they say there is no parallax found between the images, it means both the images should be in the same place. Now whose image is easy to find? Obviously the plane mirror. So for plane mirror, if object is 24 centimeter, image will be also 24 centimeter behind the mirror. So this is image by plane mirror, and that should be at 24 centimeter itself. That's the property of plane mirrors, right? Now for convex mirror, this is the object, remember, light is going this way, and since image should be formed here itself, okay, same distance behind. Why did I draw here? If object is here, same distance behind means here, right? Not there. Yeah, but distance will be this only, right? So this is the image. And since both the images should be here, this is also image distance for now your convex mirror. And what will be that? Well, this is 24, this is 24, this is 36. What will be this distance? 36 minus 24 will be 12, right? Let me put circle, okay, because it is not given in the diagram. And this is 24, so what will be this? 24 minus 12, this will be also 12, isn't it? So for convex mirror, what is object distance? Minus 36. What is image distance? Plus 12, because it is on the right side, or I should say actually incident ray will go this way from object to the mirror, the shiny part of the mirror. and we have to measure distances from the pole. So from pole to this, when I go image, it is positive. So plus 12. So formula is 1 by v plus 1 by u equals to 1 by f. So 1 by 12 minus 1 by 36 is equals to 1 by f. 12 3s are 36, so this will be 2 by 36, 1 by 18. So f will be 18, right? This is 2 by 36, right? So 1 by 18. So you do ulta, f will be 18. So radius of curvature is twice of focal length. So it will be 36 centimeter. Okay. So next question is, they have kept a small linear object whose length is b. This is the length, but it is, remember, very small. Compared to what? Compared to this u. And u is the object distance of this from the mirror. Which point actually doesn't matter, because they told this is very small compared to this, right? So this or this can be approximately taken same. And focal length is given f. We have to find length of the image. So here this is an example of where object is kept parallel to principal axis. At that time we have to find longitudinal magnification. Longitudinal, which is length of image by length of object and kept parallel to principal axis. Okay, and for small objects I have shown in the class that ML will be m square, where m square is the, where m is the lateral magnification, hi by ho. And that m formula is what? F by f minus u. But here we have to put which sign, so be careful. So focal length is given f, so minus f. Here minus f, minus plus u. U is minus u. Remember, this u is our formula u. This u is the given u. You can think of this as 10 centimeter. So while putting in mirror formula or magnification formula, we have to put which sign. So if this was 10, you have to put minus 10. So here they gave you u in the question, so you have to put minus u whole square, and that will be f by u minus f whole square. Okay. So if you cross multiply, the length of the image will be ml times length of the object, which is b, and this is f by u minus f whole square times b. And if it is f minus u, even then the final answer will be same, because there is a square. Okay.